as powerful as you might need it to be, it doesn't have all the sort of accoutrements that you would want in a modern development system, but it's still all there in theory and elegance. And I will probably continue to, as I carry my iPad around. It's sitting on the last airplane flight I took. I wrote a Sudoku solver in there because I was sitting there with my iPad and the Sky Mall magazine, whatever. So that ability to kind of do random programming at random times has been useful for me. It's taken fallow hours that I would otherwise not be doing something particularly useful for and let me do something that's actually creative and programmer growth inducing. And so functional team-wise, the idea of it's obviously not possible for me to go and say, okay, everyone it is, we're going to work in Haskell now. This would just be not good for all sorts of reasons. You want people to work with the tools that they're comfortable with. And it's actually something that's been challenging for id, specifically in recent years, in that there is an industry way of doing things, and there are zillions of people that are just aces at Unreal and Unity that have skill sets that are hard-won and working to something that's a very different paradigm, different way of doing things, different tools. There is value lost to the world when you take somebody that's expert in one thing and make them be a novice in something else. There's also the upside from that, where when I was going on about Haskell, I had one of the developers at id obviously went and looked into it, and he came into my office with this sort of cross look on his face, and he's like, what the heck is all this monad crap? And I sort of understand that, where if you take somebody that knows how to program, and you say, if you take a person that knows how to program in C, and you say, well, here's Python or Perl, and you look up the correspondences. Okay, here's how you get the time, here's how you call functions, here's how you deal with the file system, and it's just a matter of translating what you know into another language. But going to functional programming is a different thing, and it's sort of, and to get the most out of it, you have to sort of embrace newbie brain. You have to be able to sit back and say, I'm not an expert, I'm not a master of my domain. I'm going to go back and I'm going to learn something that's fascinating that I don't understand, and I'm going to be groping around for a while, not knowing what I'm doing. But in the end, there may be some insights out of it. But you can't drag a whole company into that. What I'd love to see somebody doing is, I do think there are real benefits to it, and the Haskell ecosystem is improving. There are some companies using it for commercial work, but it's still not industry grade. But I think that there's a great opportunity for a team, if you've got a small, cohesive team, to be the functional programming team and figure out how to make mobile games or make web games or do things that you can iterate on, that you can do these 6-month project cycles to learn the lessons and the things that we learned 20 years ago with the development systems that we use now. And there's an opportunity, I think, that goes on for years of evolution. People do things, hopefully keep their heads above water, land the contracts or sell enough of the different things, but evolve to the point where you've got a team of ace people that can then take on a big, challenging, important, valuable project. When you are ready to write millions of lines of Haskell code, you don't want to go into that blind. You want to have bootstrapped it up through a number of small projects. And there's no amount of seminars and exercises and learning that you can get to that without going through the projects. The whole project cycle of starting it out, having your missteps, figuring out where you went wrong, correcting, releasing, post-morteming, and going through all of that. So I hope there are some groups out there that are doing just that are core people probably from college that that are into functional programming. Go out, do valuable things, build the skill sets, and turn into something powerful, something that we can look at 5 years down the road and say, man, they are just kicking everybody's ass because they made some right decisions early on and have built up the skills necessary to do that. And I guess that's probably about it. So I'm not too far off time. So I'll take I'll take questions now for as long as anybody wants. So do we have a microphone that we can get out into the audience? Yeah. Do we have a microphone? Anyone here? Okay, you can yell really loud. Say again? Yeah, so it was interesting. A couple of weeks ago, I was trading some email with Elon Musk from SpaceX, and I was talking about I'm excited about these virtual reality things and other stuff, and then he kind of hits me with this, well, if it's not on the path towards colonizing Mars or making the money to fund colonizing of Mars, it's just not that important. He's like making me feel guilty for not thinking on a planetary scale. And yes, Elon is serious about all that, and I respect the hell out of him on a whole lot of levels. So earlier this year, we crashed the last rocket from Armadillo, and I did spin down most of the development work for this year. We're talking to some investors, different things right now, but I made the play 2 years ago that I was gonna go for it, for what we thought Armadillo needed. We thought that we were within striking distance of the suborbital cargo markets,
Sure you get
the NASA cruiser payloads, and there were a lot of people interested in working with that. We're working with, we flew payloads from people at the European Space Agency and some universities locally, and it looked like it was achievable there, that there was enough market to make the business case close. But the state that we had been in, we got to the point where we were scraping by. I mean, we had an operating profit, but it was doing contract work for other people. And I reached the conclusion that we just weren't going to get where we needed to go with that. There's this tempting thought that if you work for contracts people and you pick the right contracts, you'll be developing things that you wanted to develop anyways, that it will help you towards your goal. And there's many companies that have taken that explicit tack. And as far as I can tell, it's not working. It wasn't working for us. We were keeping the lights on, we were building rockets, but they weren't the things that we needed to do. So about 2 years ago, I made the call that, okay, we're going to cut out all this contracting work, no more NASA, Air Force, rocket racing, whatever. And I was just going to dig into my pocket and say, I'm going to spend what we need to on the development, which turns out to be something north of $1 million a year to run the team. We had 8 people on the team. We have a large hangar. There's mills and materials, and the operations of going out to New Mexico to fly. It costs $1 million a year, and maybe we could have saved a little bit more on that. But I went into it thinking that we can do this in 2 years. The arguments that I would make is we had, like clockwork, almost since the beginning, for over a decade, we had built 2 new airframes a year, and we learned immense amounts. It was great. We would build these crazy different things. We built the manned rocket planes. And so I thought, okay, we're at this point. We have the propulsion pretty well understood. The numbers close. It looks like we can do this. We're just going to repackage the things that we're doing into these more tubular-sounding rocket arrangements. And it seemed like a perfectly good plan. Everything makes sense. But what happened was disappointing, and we have arguments somewhat about exactly what the causes of this are. But when we went to do that, what should have been faster repackaging of everything turned out slower, and we built 2 airframes the first year, and then the second year we wound up only building 1 airframe. So things had regressed and were going slower, where we should have been able to turn these things out in series. We made less progress. So we got a bunch of things flown. We flew to 94 kilometers with 1 vehicle. We had at least 1 completely successful recovery with or 1 guided recovery back on the steerable parachute, which is wonderful, coming down, landing the rocket in front of the pad. The individual pieces came together, but we didn't get a mission that had everything work together properly. And we were flying people's payloads on this. They were sort of like at your own risk. You can put them up. You might get your payload back. There's a good chance we're going to crash. We had Purdue University put a payload on practically every single rocket. And they got to learn a lot because they had cases where their stuff didn't trigger, or our stuff made a smoking hole in the ground, or our stuff recovered, but their stuff didn't turn on right. And we went through a lot of useful learning experiences there. But we also had some fairly expensive payloads from the European Space Agency folks that we were flying on there. And they knew it was at risk, and we didn't take their money when we didn't make a successful flight. But I was disappointed that it didn't turn out better. And I have a few theories on why it worked out that way. The point that I try to avoid, it's a hubristic point, is that I wasn't as involved with Armadillo in recent years. I had smart guys there that I felt were competent. I respected their directions, but me not being there left me in the position of not wanting to second guess the boots on the ground when something would come up, and I'd be like, I kind of think you should be doing something the other way, but if I'm heads down on software and they're the ones there every day working on things, I didn't feel really justified in. I never want to be that manager that's out of touch with what's going on in the engineering, that's just saying, back in my days we would have done it this way. So I let my hands off the wheel there, and we can't make an A/B comparison about how important that may or may not have been. But there were some of the things that I term creeping professionalism that came into it, where in the old days at Armadillo, we were all about, okay, here's an idea, run down to the shop, grab the saws and the welding gear, slap something on the mill, and you've got something next week, and it's fabulous. But as we did more contracting work, we started having, and as people got full-time, we would have big engineering drawings. Lovely stuff comes off the plotter with all the information about it. We have our revision controls and our document systems. And of course, NASA loves seeing all this stuff. It gives everybody that's contracting a good set of warm fuzzies to get stuff you hold in your hands on the engineering documents, and to know that we had a preliminary design review. And all of this makes people feel good when they're paying for engineering, but it definitely slowed us down. Some of it may also have been the move to full-time employment, where there was when we were all a volunteer team, when it was just me paying the bills and everybody had a full-time job, and we came here and we worked on rockets a couple days a week, everybody was really focused on getting the work done. If you know you're going to be here for 5 hours and here for 8 hours, there's not a lot of time for goofing around. And we had a little bit of that when more people, we sort of hit a critical level when we had a couple more volunteers, and I noticed productivity actually dropping. We paired out some of the volunteers and productivity went back up. So there was certainly some of that effect when you get everybody and it's your job. You go in and you check your mail and browse the web a little bit in the morning rather than going first thing down into the shop. And the people that I had this thinking that, okay, people are working 20 hours a week part-time, and they still got a full-time job. We should be able to get 3 times as much stuff done when everybody's full-time. But it didn't work out that way at all, where when rocketry was people's full-time job, they got other hobbies, and they did other things with their 20 hours a week on it, and then your 40 hours full-time a week is very rarely 40 really good hours for most people, when you wind up having all the little things you do at work that are not really work. So there's a number of things that may have contributed, and we're still tantalizingly close. One of the bad things the things that we didn't do is we should have made series production we should have made multiple vehicles at once. And we did this years ago with our modular vehicles. We made parts for 5 of them. And that served us so well. We got to crash every single one of them, but it wasn't that traumatic because we had more pieces there and we just built another one. We desperately should have done that with these 2 rocket vehicles. And that was our critical mistake in the last 2 years, because we should have been able to put more of these together. Creeping performance was another thing where we used to just make everything out of aluminum. It's not like the highest tech material, but carbon fiber started creeping into our development systems here. We started heat treating our own aluminum rather than just using thicker aluminum, and all these other things and this is chapter and verse for some of the errors that NASA has done over the years, and it's heartbreaking for me to see my own team following some of these problems. But the situation we're at right now is things are turned down to sort of a hibernation mode, where we've still got people maintaining the shop. We are talking to some other investors. If anybody wants to kick in a couple $1 million to build rockets, give me a call. But it's probably, if we don't wind up landing an investor, it'll probably stay in hibernation until there's another a liquidity event where I'm comfortable throwing another $1 million a year into things. And the rocketry has always been it's been a negotiation with my wife, understandably so, where she has always insisted that I not be one of those celebrities that squanders all of their fortune, being high on the hill and then penniless someday. So rocketry has always had this carved out area where this is John's crazy money, while all of this is to make sure that the family will be well taken care of and John's not going to be begging for work sometime. But I basically expended my crazy money on Armadillo, so I don't expect to see any rockets in the real near future unless unless we do wind up raising some investment money on it. Okay. Yeah. Oh, so we do have a mic. Good.
Thank you. You were talking earlier about the differences in technology between CPUs, Intel, and AMD. What are you seeing, in your opinion, between GPUs with AMD and Nvidia with the current technologies? And also, can you please sign my license plate?
Sure, I'll be around here after the talk.
Great, thank you.
So I have not done side-by-side direct benchmarking, so you can't. I can't make a definitive statement on AMD versus Nvidia on the graphics card side of things. I mean, as far as I can tell, when I have looked, AMD is occasionally faster. Their hardware is certainly top-notch. It has always been this driver and software ecosystem that's made me tend to stay with Nvidia. Nvidia's had a really spectacular team there, and the AMD people are working hard, but Nvidia at a strategic level has just piled a lot of really powerful people onto making that software ecosystem really good. But AMD's continuing to get better. Intel's getting better on the software side. There used to be just the horrible. There used to be Nvidia with good OpenGL drivers and everybody else in various levels of awfulness. But now the big three of Nvidia, AMD, and Intel are all pretty good. We can ask for better in most cases, but I'm not unhappy with any of that. On the CPU side, we did benchmark some recent AMDs for our baking stuff that we do for making the MegaTextures, which soaks up hundreds of cores of CPU, and they were still. They still lagged Intel on the performance standpoint a bit there. On price performance, if you could throw enough cores at it, they're arguably a win in some cases, but we wind up being sort of box limited about wanting to throw as many cores into one box. And we benefit from not fighting with blades versus having larger systems with dual sockets and everything. So they're doing great work, and I think that, I feel bad even having to make the statements about whenever somebody really draws me out about, okay, which do you prefer? Well, I do prefer Intel and Nvidia personally, but AMD is doing great work on so many things, and there's lots of cases where it doesn't take a large other reason to overshadow the difference in performance and value metrics that I'm looking at. It's great to see a bunch of competent people working on lots of different products. Yeah. I can't. I actually asked about whether I could say anything related to the development, and the answer was no. Yeah. We can ping pong. You can come back to you. Yeah. Yeah, so in some ways, I do feel a little nostalgic sometimes for the glory days of microprocessors, when I'd be happy getting my microprocessor report to hear Spark versus PA RISC versus Power versus x86 versus ARM, and now it really is x86 and ARM. I mean, PowerPC is still there for the Wii U and for some embedded things, but it's clear that we're getting a duopoly, and I always find it remarkable how Intel had the strong ARM technology from DEC, when DEC fell apart, Intel had the world's best ARM processor for years. They did nothing with it and eventually divested it, and now all of a sudden the ARM stuff is super important. So I would betting against Intel on an engineering basis is a CPU engineering basis is probably really, really risky. Now, I mean, they don't look as invincible after sort of flubbing the Larrabee stuff, but they still probably have the best guys at the circuit, at the low-level circuit layer when you're looking at things at the process level and how to get the very best out of not some synthesize out of a bunch of RTL core logic stuff, but when you're going down saying, we're going to make the most efficient thing, they are probably better at it than anybody that's making ARM processors. The baggage of the x86 is really not as much as a lot of people would think. When you can look at it as, in fact, there was a lovely article that came out in this last year about trying to analyze the real importance of instruction sets. And there was a bunch of data through there. I heard people contesting the results of it. But the result that was reported was that the architectural overhead of the x86 instruction set is really not that much. It's offensively ugly from if you look at the manuals on there about how much is devoted to all of it. But in terms of what it costs you in terms of power and silicon, it's not that large. Now, whether x86 is going to be able to compete in I don't look forward to a multi-CPU like Android ecosystem, back to fat binaries and runtime translation. That's not a happy thing, really. And whether Intel would ever swallow their pride and make another ARM core, I mean, they could probably make a really, really strong ARM core, but that does not seem to be their plan of record. Pushing with Atom, I think they're going to have adoption problems with it, even when they do probably wind up starting to win benchmarks, power benchmarks and all that. But they do seem committed to it. They know the writing's on the wall. This is already far more processors are sold there, and eventually the raw dollar volume is going to be larger in the ARM space. I mean, right now the margins are spectacular for x86, but that's not going to last because more and more things are being chewed up by the transition to mobile devices. Yeah.
No.
Okay. We have
over here.
Mac. Okay.
Oh, sorry.
Yeah.
Given the two new consoles that are coming out and their unified memory and their connection to the GPU, have you been looking at anything concerning abstract algebra, like monoids, semigroups, concerning that parallel computing power that you now have access to with low latency?
So as far as using the GPUs for the additional processing, that's one of the things we're a little bit behind the curve on right now. I did a bunch of OpenGL work a few years ago, but we are still sort of hand-waving our exact strategy for how we abstract between the different interactions for the OpenGL versus direct compute, and possibly using compute shaders in different places. So we're not all sorted out right there yet. I'm not completely positive how many places we're going to use it for. There are complete no-brainers, like building particle systems. And some of the particle system works is no-brainer work for doing compute. But some of the things, collision and some of the decompression stuff, there are benefits to be had there, but they're not as huge as you might think from the flops count. I am very excited to see how the tight interactions using shared memory, having the unified space, being able to just pass buffers around, having low latency compute job dispatches that aren't all serialized through the graphics command buffer. There's a lot to be done there, and I need to write more code. I mean, it's been a few years since I wrote any compute shader things, and there's more that I need to personally pick up. Yeah.
I was wondering if you could talk about IDTech 5, and it's been out for a few years. Has there been any big changes with the engine since Rage came out?
So we're not dramatically changing anything. The fact that Wolfenstein is still cross-generational, where it's still going to have a 360 and PS3 SKUs, meant that you can't make a super dramatic difference change in there. Lots of things get cleaned up a little bit better. We are still pulling out some of the minefields of things that we had to over-optimize for the previous generation. But it's a little bit of an awkward time as we have these titles that are shipping on current generation hardware. The thing that's been most painful about it, that I still feel the most, is the disk size limitation, where if we had infinite space, there would be, I wouldn't feel at all bad about the decisions that we've made. We'd quadruple up the resolution in all dimensions, but we can't ship that on all the optical drives. I think that if we can wind up streaming that from the cloud to all the different platforms, there's a lot of possibilities there. But we still have a lot of discussions internally about the wins versus the costs of static baking for some things, how we couple it with dynamics. So there are continuous arguments going on, but most of the work right now is getting more physically plausible materials, bringing the high dynamic range with accurate interpolation of different things. Stuff that's, I'm actually been, for a couple months now, I've been sitting with the artists. I moved out of my office and just kind of plopped myself down with in the middle of the art team so that I could hear them bitching and moaning about the different things and try to prioritize what needs to be fixed, what needs to be addressed. Because so much of it has been just education. There are so many things there that we can do a great job of if you approach it a certain way. And as we've hired lots of people, like I mentioned before, the issue about hiring from different studios that have different technology pipelines, a lot of people just wouldn't know the right way to properly set up your environment maps for things, or the right way to tune something, or what should be in the different the channels of the textures. So that's where most of the visual differentiation is coming out now. And it has to be that way because there is push to get your latest bullet point GWiz feature of, okay, you need to do this, 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 and this to be next gen, but there is so little that you can just throw additional technology at the same set of media and make a difference at right now. It is not the right way to go. We do need to get to physically plausible materials for everything so that so the global illumination can act properly. Like in Rage, we had global illumination where you could drop a nice light and it could light everything up, and because it was baked, we could do a high quality job on it. But we had the diffuse maps. If you look at the textures, most of them are half or a quarter of the level that they should be. So there's all these fudge factors going on where global illumination had in many maps a 5x multiplier assigned to it because the diffuse maps were just completely implausible. So there's this education that we have to go through. And I tried to do this several years ago, and it wasn't the right time. We were too busy with Rage and the other things, and we had too many entrenched sort of ways of doing things. But that's at least progressing now, and that's our big thing, much more so than any specific technology, because you can't address the technology for a lot of those until you sort of get a handle on the source data, and we haven't had it really sorted out. Yeah.
You mentioned before that the Doom franchise to you meant demons and shotguns. I'm curious what id Software means to you from the standpoint of a founder and of course, longtime employee.
Well, I've made the comment before that I really don't think much about the past and legacy. I mean, I commented that I'm a remarkably unsentimental person. That's when it's brought to my attention, like at QuakeCon, it comes up and we're like, look at this. It's like, oh, we did this 20 years ago, this 18 years ago. Look at wasn't it cute back then with the run room at the small hotel? But I don't think about it much. I'm happy. I'm proud of a lot of the things that I've done over the years, but I've never reached a point where I want to really sit back and reminisce about them. Just heard me talk for 2 hours about all of these things that I'm super excited about going forward, these things that I want to see happen in the coming year, things that I hope I can nudge somebody into changing the way they're doing it because it'll affect me after that. But the id Software, with what we've done, it's probably still, it's going to be the legacy of, we invented the first-person shooter. And I resisted that for a while, really, because I sort of had this hope that that there could be other directions and things that we do. Early on if we look back to the very first projects there, we went, Keen to Wolfenstein to Doom to Quake. There was this intentional sense that we are hopping between genres because, we want to show that we're not tied to just what we've done before. But in the end, when things reach the scale that we're at, the development team size, you do kind of wind up sticking with what you're known for and what you've what you've done. And that really is the legacy of id Software. And it's certainly not a bad one. I think FPSs are going to be here forever. Just like we will always have driving games and fighting games. We will always have FPSs now. And we started it. So that's, I'm pretty proud of that. All right.
So in the past, the PC kind of drove, gaming and the power and everything. And when you